10, we will discuss rational expressions. In Module 10, Section 1, our focus will be simplifying rational expressions. Let's start by defining what a rational expression is. A rational expression is an expression that can be written in the form p over q, where essentially p and q are polynomials. This is just a fraction with algebraic expressions. To evaluate a rational expression for a particular value, we substitute the replacement value or values into the rational expression and simplify the result, just like we would in any other type of algebraic expression. So let's evaluate the following expression for y equals negative 2. We replace every y value with a negative 2. This becomes negative 2 minus 2 over negative 5 plus negative 2. We simplify numerator and denominator, and this gives us negative 4 over negative 7. And remember, when you divide a negative by a negative, that becomes a positive number, so positive 4 over 7. In the previous example, what would have happened if we would have tried to evaluate the expression for y equals 5? Let's try it. So we replace every y value with 5. That becomes 5 minus 2 over negative 5 plus 5. 5 minus 2 is 3. Negative 5 plus 5 is 0. And if you will remember from way back in Module 1 and Module 2, if we divide by 0, we say this value is undefined. Values for which a rational expression is undefined, we want to find values where the denominator equals 0. Let's try to find any values of this rational expression that would make the expression undefined. When we do so, we ignore the numerator completely, and we take the denominator and set it equal to 0. In this particular example, 15x plus 45 equals 0. We want to isolate x, so we subtract 45 from each side of the equation. That leaves us with 15x equals negative 45. We divide both sides by 15, and we will be left with x equals negative 3. So the only value of x that will make this expression undefined is when x equals negative 3. Let's try another example. Here we have x squared minus 4x plus 3 all over 6. Typically, we would set the denominator equal to 0. But we know that 6 never equals 0, so this would never happen. Or we could say that it's always defined. There is not an x value in this situation that would make the denominator 0. For example, we have x minus 11 over x squared minus 5x minus 14. So we set the denominator equal to 0. And we recognize that we have a quadratic equation in standard form. Anytime we have a quadratic equation, we have to factor. So we factored in Module 6. We also factored in Module 9. Here we don't have a GCF. The coefficient of x squared is 1. So we can go ahead and split this into two binomials, where the first terms are x. We're looking for two numbers that would multiply to give us negative 14, but add to give us negative 5. And those two numbers would be 2 times negative 7. So we fill in the missing parts of this binomial with a positive 2 and a negative 7. Once we factor, we use the zero factor property to set each factor equal to 0. So we have x plus 2 equals 0. We subtract 2 from each side of the equation, and we have x equals negative 2. We take the second factor and set it equal to 0. We add 7 to both sides, and we're left with x equals positive 7. So we have two values that would make this algebraic expression undefined, and they are negative 2 and positive 7. Now let's talk about simplifying rational expressions. To simplify a rational expression means to write it in lowest terms or simplest form. To do this, we would use the same fundamental principle of rational expressions that we did in Module 1 when we were simplifying numerical fractions. Essentially, we want the same factor in the numerator and denominator, and then they will cancel out. So here are the steps to simplify. Step 1, we completely factor both the numerator and denominator. Step 2, we divide out factors that are common to the numerator and denominator. This is the same as removing a factor of 1. When simplifying a rational expression, we look for common factors, not common terms. Factors are two numbers or expressions that we multiply. Terms are expressions we add and subtract. We cannot cancel things that are caught up in addition or subtraction. Let's try an example. We want to simplify 7x plus 35 over x squared plus 5x. So we start by factoring both the numerator and denominator. In the numerator, we can factor a GCF of 7. That would give us 7 times x plus 5. In the denominator, we have a GCF of x. That would give us x times x plus 5. And at this point, the numerator and denominator are factored as far as they can be factored. So we look at the factors in the numerator. We have 7 and we have x plus 5. X plus 5 is one factor. We don't say that's an x and a 5, just x plus 5. And in the denominator, we have x and x plus 5 as well. So the common factors are x plus 5. We cancel those, and we are left with 7 over x. X squared plus 3x minus 4, all over x squared minus x minus 20. So again, we want to factor the numerator and factor the denominator. Now, neither numerator nor denominator have a greatest common factor, so we go right into the process that we've used before when the coefficient of x squared is 1. In the numerator, this will break up into two binomials where the first term is x each time. We then need two numbers that will multiply to give us -4, but add to give us a +3. And upon further investigation, you'll find that those two numbers are 4 and -1. So we fill in the gaps, +4 minus 1. In the denominator, we also have a coefficient of 1 for our x squared. So we have two binomials. The first term of each is x. Now we look for two numbers that will multiply to give us -20, but add to give us a -1. And as you go through that process, you will find that those two numbers are 4 and -5. So we fill in the gaps again, +4 minus 5. Now our two factors in the numerator are x plus 4 and x minus 1. The two factors in the denominator are x plus 4 and x minus 5. So the numerator and denominator have a common factor of x plus 4 that we can cancel out. And the factors that are not in common, we write down again, x minus 1 over x minus 5. And that would be the answer. Well, we want to simplify 7 minus y over y minus 7. Now in this case, it really doesn't look like we could factor anything. I'm going to show you a little trick we can use in the numerator, and sometimes we'll use this in the denominator as well. 7 minus y, if we were to factor out a -1, that would change the sign, because remember, when we factor, we're dividing each term on the inside. 7 divided by -1 is -7. -y divided by -1 is +y. And if we were to rearrange the terms inside parentheses, this would become -1 times y minus 7. So this is a useful trick when something is different. If something differs by just a negative sign, we're going to rewrite it. We factor out the negative sign, and essentially we reverse the order of the subtraction inside parentheses. So let's put this back into the original expression. This becomes -1 times y minus 7 all over y minus 7. So the numerator and denominator have a common factor of y minus 7. Those cancel, and we were only left with -1. Example where the numerator has 4 terms. Hopefully you remember when we have 4 terms, we are going to factor by grouping. So the numerator is x squared plus xy plus 11x plus 11y, all divided by x plus 11. When we factor by grouping, we group the first 2 terms together and the last 2 terms together. And we are basically finding 3 greatest common factors. Once we do that, we will be able to cancel a common factor with the numerator and the denominator. So when we look at the first group, x squared and xy have an x in common. So we factor the x, and that leaves us with x plus y. In the second group, 11x and 11y have an 11 in common. Once we factor out the 11, we are left with x plus y. To get our third greatest common factor and finish the factoring by grouping, we look at the binomial that each term has in common in the numerator. So we factor that binomial to the outside. That gives us x plus y times the resulting polynomial is x plus 11, all over x plus 11. So the common factor in numerator and denominator is x plus 11. We cancel those, and we are left with x plus y.